Alrighty, James, this one is for you, my friend. Let's go through my current method of getting to an analysis. And in traditional work, you never measure a rotated or tilted skull. I guess you measure a tilted skull. But I like to just prepare my frontal and horizontal before I start my analysis. So let's get this rough through the middle of the head. And we start by taking the rotation out on this through the whole skull dimensional transpositioning. And so as I roll, I'm looking to see, do my orbits close symmetrically? And they don't, because if I come up here and check the orbit, I'm only on this part right here, but I'm not on the other side. So let's align this to the orbits. And now, as I roll through my frontal, my orbits should close together better. Try to get it perfect. Wrong direction. And when we do this, we're not just taking the rotation out of the frontal, but we're establishing the horizontal cranium line. Because if this is unrotated, this should go straight through the middle. And so now I roll to look, are my other parts of my skull appearing symmetrically? Are my jaws coming into view at the same time? And pretty good. Are my inner ears coming into view at the same time? And here it is, and pretty good. So I think this is the best horizontal cranium I'll be able to get, and this is an unrotated frontal. Then I do the same for tilt. So if I come to the floor of the occiput on the sagittal, I can see it here, and again I'm looking for Mickey Mouse ears. Are those symmetrical? I see one slightly larger on the right than on the left, and so if we add some tilt to level out the floor of the occiput, when we do this, now we're getting a nice view through the base of the occiput, and I'm just using that as my head tilt. Okay, it's basically like going straight to the condylar aberrancy. So if I open up my window and I open my main calcs and I clear out the old stuff, then all I need to do here is measure this head tilt. So toolkit, vertical angle, let's put one point of it way up on top. Let's put one angle of it way down on the bottom. And it looks like on this woman, her head is tilting to the right by 1.34 degrees. And that is the first measurement I need. So, after this, what I like to do is come back to my cone beam and prepare my atlas shots. And typically in traditional work, we would look at the atlas along the atlas sagittal plane line. So by orienting to my atlas sagittal plane, I can see everything I'm going to need. And the way I've been saying it is that we're taking the x-ray by positioning these and then we measure. And so here's my atlas. And as we come through the front of the atlas, where it's higher, we're going to see a little bit higher peak. But as we roll more to the middle of the atlas, it comes down lower. And the reason why is when we look sagittally, it's a lower part on this part of the atlas than on this part of the atlas. So then the question is what part of the atlas are we looking for? And this is where I'm running into trouble. I think if we thicken this slightly, we see all those planes of the atlas superimpose. And that's a really good way to measure. So let's go ahead and zoom in and play with the contrast till we like it. And open the toolkit. And if we put a horizontal angle on this inferior lateral mass, that's going to be one of the measurements we need. And we can go ahead and tinker that. And that looks pretty good there. Okay, so I'm going to go with 2.29 high on the right for the inferior lateral mass. And for our superior lateral mass, it's a little bit harder to see when we're thicker, but I still think it's a better way to look for it. And it's kind of what we're used to. Okay, so I'm going to go with high on the left at 1.95 degrees. And now we should have our ACD of a left 0.6, and the average plane line between these is a 0.17, 0.212. There we go. Okay, so that's that. Let's go ahead and jump from here to our condylar axial circle. So, this is interesting, and I think you've seen me do this before. What is the plane that we should be viewing? Should it be down the atlas sagittal plane? Should it be more along this axis posterior body, which will give us a view like that? But I don't think that's flat through the axial surface. I think we see the axial surface flatter halfway between the axial angle and the sagittal plane. So that's where I measure my C over A. As well, I like a little bit of thickness, and I can see everything I need to see. So we'll zoom in, sharpen that contrast a little bit, and then we need to draw a little horizontal line, and if I hold shift, it stays flat. Okay, so once that is right where I'm going to want it for my analysis, we'll open toolkit, and we're going to hit calibrate, and we're going to place this line directly over that horizontal line we drew. Plug that in as 2.95, and we're going to use a condylar circle to map the 4 points we would do for that side of the joint. The 1, 2, 3, 4 for that side of the joint. And we'll do the same thing for our axial circle. Icing on the cake. And here are our circles. Let's hit auto load. They fall right in. And we are done with the condylar axial circle. Okay, for the cervical spine, while we're here, I like to take this and orient it down the neck. Let's get that midline, and it looks like her neck is going kind of that way. Okay. So, I try to crop out this image. And then we're going to open this guy up, and we're going to use this little center point tool. And we just got a color changer on here. So let's change this to something easier. Magenta. There we go. I'm going to mark the outsides of the joint, but I also like to mark the inside of the neural canal, since we can see it on cone beam. And I would say that you could just draw a vertical axis through all of these and call it a day, if you wanted to. But traditional work says that this top point should be halfway between the dens and the C2 spinous. So if I jump back to my viewer and we roll till we see that spinous, hers is fairly off to the right. Now, if we were to center point this dens to the tip of that C2 spinous, we find that the top of the line should be here. So let's put this on the base of the neck, and then halfway between those two, looks like it's right there. And in reality, this woman's neck is tilted to the right by 1.08 degrees. And that's how I'm measuring my cervical spine tilt, as close to traditional as possible. Okay, so let's go ahead and try to see things again. And we are ready for our horizontal film. And what's good is this line we haven't touched is still right through the middle of the skull. I like to view my atlas on this along the atlas sagittal plane. And so now as we descend, through her skull, right, there's the bottom of the atlas, there's the top of her atlas, and here's the floor of the occiput. So let's roll till we can see her superior, posterior, lateral masses. That's all condyle. Here's atlas appearing, and there it is, the back of that joint. So we can put the protractor on this horizontal skull line and arbitrarily put that there. If we move this here, we can measure our atlas rotation. And we're getting 3.56 degrees, posterior on the left, anterior on the right, 3.56, and there it pops in the rotation as a posterior 356 for left laterality. Very good. Then we're going to go back to the cone beam, and what I like to do at this point is center point my dens. Let's jump back to the cone beam and scroll down till we see the C2 spinous, which is off this direction. And now, when we place our protractor back on our horizontal skull line, I did that wrong. Let's try that again. Good to know. Okay, so if we put this guy right on the middle of that dens, which was there, and we put this on the spinous process, we can see that this C2 is rotated to her right side by 8.03 degrees. So C2 is to the right, 8.03. And we have all of our measurements now. Last thing I'm going to do is jump back to her 3D, and let's take it as a posterior shot. I haven't checked that that's perfect, but close. And if we pop this open, we have show misalignment now. And her right is on this right. We'll drop this down to her plane line. We're going to take this guy and put it on that lowest spinous, and this will go through her head tilt. There it is. I like to snip one of these for my report. Whoa! And the snipping tool killed it. Glitch. That's okay. But you get the idea. And so this is kind of how I've been analyzing these so far. With her atlas high on the right, we see a pretty large right laterality here. And this is important because look here. See, it's shoved over to the right. And so it's higher on the condyles on the right. And this is my latest brain fart about this, is that if we look at our image, we have aligned this yellow axis to the floor of the occiput, and we're coming down to look at our atlas along the plane of the occiput. So we're coming down on the atlas, layer by layer by layer. And right here, we see the atlas on the right side because it's higher. Right here, we see atlas appearing on the right side more. And so we can't measure our rotation from this shot because we can't see the back of the joint. So we end up going lower till, okay, now we can see the back of the left. We see the back of the left, back of the right. But you look here, we're not going through the same part of the atlas. We're going through a lower part of it on the right and a higher part of it on the left. And this is my issue now, is that if we were to measure this rotation along the tilt of the skull, atlas is here, and atlas is there. Okay? That's right where atlas is. However, if we were to more look at the atlas rotation along that superior plane line, now, where is that atlas? Look, now we see it showing up symmetrically because we're on the plane of the atlas. And now when we look at those joins, half a degree different. Half a degree difference isn't a lot, but this may be happening in other places we're not looking. Okay, this case had how much rotation? 3 degrees of rotation. So let's do the same thing on that view. Right now, we're looking at the plane of the atlas along the center of this skull. And so when we look at the plane of the atlas, when we're oriented through the center of the skull, as would be a traditional frontal, we're going to have a plane line up here and here. But if we took this view, and instead of looking at it through the skull, we were looking at it through the atlas head-on, would that change our measurements? Over 2 degrees. See, this is what I'm saying, is we can't just look at these cone beams without modifying the perspective we're looking at it. And right now I've been doing things on the perspective of traditional filming, where we look at it through the middle of the skull without tilt on the horizontal, and we look at it through the frontal without rotation. But when we look at the frontal, when we're rotated through the atlas, it changes the measured plane line because we're viewing different parts. And so I think the workaround for now is that we do a thicker slice. And if we look at this atlas like this, where we're looking through the whole chunk of it instead of one slice of it, everything superimposing, we should be able to get more consistent measurements. And I think that's how they got away with this on X-ray. .3, so that's more consistent with the initial one. So that's how they got away with it, by having X-ray superimposing everything. Then it didn't matter the thin slice, but it is something we need to be a little weary of when we're measuring all this on a single slice. It's, hey, it's easier to see, it's right there, nothing superimposing, but we may not be measuring through the same parts of the atlas, and that may be changing what we're measuring. So more or less, this is kind of where my analysis is at these days. I like to grab a snip of this for my listing card. Right now, I'm manually entering this into Sonus, but we will have that automatically done within the next month, hopefully. And bada bing, bada boom. I hope this clears up your analysis questions, and I look forward to your feedback.